with 1.5b. And this could have been its own lesson. Like they could have done parametrics as its own lesson and then 1.5 as its own lesson also. But this part of the 1.5 focuses on the inverse of a function. Inverse. And although you did this last year, we're going to kind of bump it up a notch and do it a little bit harder. Okay? So this one only has two parts, A and B. And the first part is we are going to algebraically find the inverse. So this stands for algebraically. If I can spell it right. Algebraically, that's an R in there. All right, so let's say you have a function f of x. They tell us that the inverse of f of x is written like this, f to the negative 1 of x. Do you remember that notation? Bless you. It's called f inverse of x, okay? And what we're going to do is we're going to do two things here algebraically. First thing we're going to do is we're going to be given a function, and we have to find the inverse of that function, okay? The second thing we're going to do is we're going to then be given a function and its inverse, and we're going to have to verify. We're going to have to prove. You love proofs, huh? I know. We have to prove. Okay, so number one, find the inverse of the function. We're going to find f inverse of x. All right, and here's how you do it. You did this in Algebra 2. You're going to take x and y, and you're going to switch them, because that's what an inverse is. It switches everything, okay? It switches all the x and y values. And then we're going to solve for y. So it's really two parts. And I have 1, 2, 3, 4 of these to do. Because there's so many different functions that you have to practice on a whole bunch. Okay, so let's suppose that our function's just a simple line. F of x equals 2x minus 7. And here's the thing about inverses. A lot of times, if we start with a line, our inverse will be a line. If we start with a rational function, our inverse is a rational function. Okay, a lot of times. But some of them are different. Like if you start with a square root, then your inverse is going to be a squared. So here we go. Let's start with this one. Let's take x and y. I know there's no y here, but f of x is y. Let's take x and y and switch them, okay? So to find the inverse, I'm going to say x is now equal to 2y minus 7. And then I'm going to go ahead and solve for y. So let's add 7 over. And then let's divide everybody by 2. So I get y equals, divide everybody by 2, so it's 1/2 x plus 7/2. And that's my answer. And you can leave it as y equals. You could also rewrite it as f inverse of x equals, either way. But those are inverses of each other. That's all you have to do. Switch x and y, solve for y. Okay, let's do another one. B. F of x equals x cubed plus 5. And we want to, once again, find f inverse of x. Okay? They'll get a little bit harder in just a minute. All right, so go ahead and switch x and y. And so we get x equals y cubed plus 5. And now let's solve for y. So subtract x to the other side. X minus 5 equals y cubed. How do we solve for y? What's the inverse function of cubed? Cube root. Good. So y equals the cube root of x minus 5. And that would be your answer. Okay? All right, so right now these are nice because these functions are called one-to-one. Okay, let's talk about one-to-one real quick. One-to-one. One-to-one functions are functions that are, well, they're relations that are functions itself and their inverse is a function. So one-to-one functions pass both the vertical line test and the horizontal line test. So not only does every x match to y, every one y matches to every one x. Okay? So for example, a one-to-one function is that line that we just did. That is one-to-one. Passes the vertical line test and the horizontal line test. The other one that we did was a cubic function. It was a basic cubic function that looked like this. That passes the vertical line test and the horizontal line test, okay? Now the problem is when we get something like a parabola. A parabola is not one-to-one, okay? Parabola is a function. It passes the vertical line test, but its inverse fails. The inverse ends up being not a function, okay? So sometimes things happen where you're going to get more than the domain that you started with. So we're going to do a couple of those. All right, so let's do number 2. And the first ones were nice and easy. The next one's going to be a little tougher. And we're going to find the inverse, again, find f inverse of x. And this time I'm given f of x equals x plus 3 over x minus 1. Whew. All right. This is one that I give my calculus students too. I just did this one with them yesterday because we're doing like a review chapter. And they still struggle on this too because this one's pretty hard. So what we're going to do is we're going to find the inverse by switching x and y. So you get x equals y plus 3 over y minus 1. The hard part of this is that there are 2 y's now. Okay, how are you going to solve for y when there's 2 of them? So let me show you how to do this. Go ahead and put that over 1, and we're going to cross multiply. Okay? So we get xy minus x equals y plus 3. So cross multiply xy minus x, don't forget to distribute, equals y plus 3. And now we need to solve for y. Okay, so this is what we're going to do. We're going to get our y's over to one side, everything else to the other side. So let's subtract this y and add that x. Can you do that in one step? Sure. Someone say no. Subtract y and add x. Okay? And now what we're going to do is we're going to factor. We're going to factor out a y to the front so that we just have one y to solve for. So this is equal to y times x minus 1 equals x plus 3. And then there's one more step to go. What's our last step? Divide. So y equals x plus 3 over x minus 1. And that's our answer. Okay? It's a lot of algebra there. A lot of algebra that you're not used to. Whoa.
So it ends up being the
Same thing. That's awesome, right? That's kind of crazy. Did I do it right? I did it right. Yeah, same thing. Ooh, did you get math goosebumps or no? No? Okay. All right, let's try another one. B. B is f of x equals the square root of x plus 3. Okay, I want to talk about this one. This one looks easy. You're going to do it, and it's going to be nice and easy, but you're going to be wrong at the end. Sorry. Okay, so first thing you're going to do is you're going to switch x and y. X equals rad y plus 3. And let's get rid of that square root by squaring both sides. So you get x squared equals y plus 3. And y equals x squared minus 3. Okay, you did it right. Everything's great. Except there's a little bit something you have to do. Let me show you. If we were going to talk about the domain and range of this graph right here, this radical x plus 3, okay? The domain is going to be x has to be greater than or equal to negative 3. And what's the range? Range is y is greater than or equal to 0. Okay? So the numbers that I can plug into here have to be greater than or equal to negative 3. And then what's coming out of there is going to be 0 or more. Now, when I go to here, and this is my inverse, the domain and range will switch. Okay? When I look at this, my domain is all real numbers, and my range is greater than or equal to negative 3. Well, that switched. That was great. But domain right here, you have to tell me what the domain is. Right now, the domain of a parabola is all real numbers. But the domain of my original function, or actually the range of my original function, becomes the domain of my inverse function. So I have to say, it is a parabola, but it's only greater than or equal to 0. Okay? Algebraically, that's kind of hard to do. I'll explain why that's what you do graphically, because graphically describes it better. Okay, so f of x and f inverse of x, when you have inverses like that, they are going to be reflection of each other. They're reflected over the line y equals x, the diagonal. Okay? So, for example, if I have, which one did we do? I kind of want to know what that one looks like, but we won't do that one. Let's say that we have, that cubic function. Let's do a cubic function and a cube root function, okay? And you can graph these on your calculator if you need to. But let's say we have y equals x cubed. Y equals x cubed is a regular old cubic function. Looks like that, okay? Then let's graph y equals the cube root of x. Y equals the cube root of x. And if you were to graph that one, it would look like this. Like that. Okay? You can graph that on your calculator if you need to. And these two functions are inverses of each other, and they are also a reflection, see if I can draw it correctly, over that diagonal, y equals x. Can you see the reflection? All the different colors and stuff? Looks pretty good. Okay? So, when I go to graph y equals the square root of x plus 3, when I go to graph something like that, and I go to my calculator and I graph it, that is the upper half of a sideways parabola. Just the upper half. It's a function, okay? When I go to graph its inverse, which I got was x squared minus 3, I go 1, 2, 3, and I graph it, and I can only do one side of it. Do you see how this side is bad? That side's not good. It's not a reflection over this line right here that goes through the middle. Only this side of it is. And so that's why you have to say, but only when x is greater than or equal to 0, just half of it. So when you start with a radical, and then you get a parabola, you have to restrict half of it. You just have to, every time. All right. Now, the second part of inverses, algebraically, is to verify inverses. Okay? Now, to verify an inverse algebraically, graphically you can verify by seeing that it's a reflection over y equals x. But to verify algebraically, you have to do this. F of f inverse of x is going to equal x. It's not going to equal 2 or 5 or negative 3. If you do f of f inverse of x, it's going to equal x. And f inverse of f of x will also equal x. Okay? All right, so let's verify one. What number are we on? Are we on 3? 3. Number 3. And I might say just verify one way. You're supposed to verify both ways to make sure that they are inverses of each other, but it's a lot of work, so I might just say just do one way. Okay? So let's verify that f of x equals x cubed plus 1 and g of x equals the cube root of x minus 1. Verify that they are inverses. Okay? Now, verification is not going to be two things that people try to do for an algebraic verification. One, they try to graph them and just show that they're a reflection over y equals x. That's not algebraically. The other one is they'll take f of x, they'll switch x and y, and they'll get g of x. And that's great, but that's not a proof. That's not a verification, okay? To verify, you have to do f of g of x and g of f of x. So let's do it. Here we go. Composition of functions. We're going to take our function g of x, which is right here. We're going to pick it up. We're going to plug it into function f. So I get the cube root of x minus 1. I'm going to take that and cube it and add 1 to it. And they don't take long. It doesn't take, well, unless they're really complicated, which the next one's going to be. And then here, the cube root and the cube are inverse functions of each other, so they cancel each other out. And you get x minus 1 plus 1 equals x, and that's what we're trying to show. If you get equals 2 or equals 3x minus 1 or something else, then they're not inverses. They have to equal x. All right, let's go the other way. G of f of x. G of f of x is going to be to take f of x, which is x cubed plus 1, and plug it into g of x now. So we take x cubed plus 1 minus 1 inside of the whole cube root. Plug it in. So you get the cube root of x cubed, which is x again. Yay! And then you're like, yay, I proved it. All right, so now let me show you. Oops, I just lost my sheet. Let me show you the next one, number 4. Now this one's tough. So if you've decided, I got this, I'm not going to listen to her, you should listen to me on this one. Okay, so this one's tough. There we go. F of x equals x plus 3 over x minus 2. And g of x is equal to 2x plus 3 over x minus 1. Now, those don't even look like inverses to me. They look like totally different functions, right? So we have f of x is x plus 3 over x minus 2, and g of x is 2x plus 3 over x minus 1. And we have to verify. All right, here we go. Let's just go one way. Let's verify that f of g of x is going to equal x. Let's verify it. You have to show all your steps in a verification because it is a proof. Okay? So this is tricky. We're going to have fractions inside of fractions. Are you ready for this? Get ready. Here we go. We're going to take g of x and we're going to plug it into there and there. Yes, you're going to love it. Here we go. So I get 2x plus 3 over x minus 1. That's going in for this x right here. And then I still have a plus 3. So far, so good? That's the numerator. And then I take 2x plus 3 over x minus 1. And I plug it in for this x here. And I still have minus 2. All right, you're okay with that part, right? That's just substitution. Yeah. But now you're like, great, now we have to like algebraically do this whole thing is going to equal x. Isn't that exciting? No, not for any of you. Okay. All right, so let me show you a nice, easy way to get the job done. This is what you want to do. Because, you know, fractions over fractions are horrible, right? Yeah, some of you are gasping. Like, what's going on here? You're going to take x minus 1 over x minus 1. You're going to multiply that to the numerator and the denominator. You're allowed to do that with fractions, right? You're allowed to multiply top and bottom by the same thing. So here we go. Let's do this. We're going to multiply here and there. And you're like, whoa, you're making this way too complicated. I'm not. I'm actually making it better. When we multiply it here, the x minus 1 and the x minus 1 will reduce. We're getting rid of that fraction. Do you see that? You multiply here, x minus 1 reduces, leaving us with just 2x plus 3. Does everyone see that? This right here and that goes away, leaving us with 2x plus 3. Then we have to multiply the 3 by x minus 1 also. Okay, that's the numerator. Here comes the denominator. Same thing. Multiply it here and here. These will reduce, leaving us with 2x plus 3. And this will be minus 2 times x minus 1. That's good, right? Don't you like that step? I love that step. It clears out your fractions. They're gone. Okay, now the rest, algebra. Here we go. I mean, this is all algebra, but this is like algebra 1 stuff. So now the rest is distribute, not that stuff, that wasn't. 3x minus 3 on the bottom. Distribute the negative 2 as negative 2x plus 2. Okay, keep going. What do I get up top? I get a 5x up top. The 3 and the 3 cancel out. 2x plus 3x is 5x. On the bottom, 2x and negative 2x cancel out, leaving me with 5. And so the answer is x. Yay! How many of those do you want on your test? 2, 3, 5?
10.
10! Yes! Let's do it. Now, you probably have one. Okay? I put this on my calculus quiz tomorrow. Shh, don't tell them. I did. Yeah, it's hard. They have to verify by doing that. It's a lot of algebra. It's really good algebra, too. Okay, let's go to part B. Part B. So we just did algebraically. We found the inverse. We verified it. Now we're going to do all this stuff graphically. Yeah?
What about g of f of x?
Oh, no, I just said we could just, well, let's just go one way. You want to do it?
Yeah.
No.
Well, I actually do have a question about that.
Yeah.
If we do plug that in, it does like 2,
Uh-huh.
and then it has x, which is the fraction. Do you
Yes.
have to plug that in?
Yep.
Okay.
Yeah. We can do, if we have time at the end, I'll do it.
Okay.
Yeah. All right, so let's do this graphically. I might ask you on a quiz or test just to save time just to go verify one way. Because if you do it twice, it's kind of like you're doing the same problem twice. You're getting the same problem wrong twice. No one wants to do that. All right, graphically. Graphically. All right, so we talked about graphically the reflections over y equals x. Now, here we go. You're going to have to just look at a graph and come up with the inverse of it, okay? So let's do, what are we on, 4? I don't know, 4 or 5? All right, so let's do something like this. They don't even tell me what the function is, okay? They're going to give me some points. So let's do this point, negative 2, 0. And we'll go 1, 2, 3. 1, 2, 3, 4. And let's say that our graph looks like this. Hi, good morning. Okay, thank you. Some interesting weird function, probably a piecewise function that's all pieced together. But here's f of x. Okay, f of x. By the way, is f of x a function? Is this a function?
Yeah.
This is y equals f of x. Yes, it is a function. Is it 1-to-1? No. It's not 1-to-1. 1-to-1 means you pass the vertical and horizontal line test. This is not 1-to-1. But we can write its inverse. Its inverse is not going to be a function, but we can not write it. We're going to graph it. Okay? Here's how you do it. Do you remember what we did to find the inverse algebraically? What did we do? We switched x and y. That's what we're going to do here. Okay? All of our x's are going to become y's, and all of our y's are going to become x's. So look at this point right here. On f of x, that is the point negative 2, 0. It now becomes 0, negative 2. So I'm going to plot that one. You don't have to plot all of them, just, you know, the key ones. This one right here is the point 0, 3. Becomes 3, 0. Okay? And this one over here is the point 4, 0. Becomes 0, 4. Perfect. 0, 4. Okay, are you ready to try and graph this thing?
No.
Yes. Oh. Well, that goes there, and that goes up there. Did I do it right? Yeah, that's pretty, no. No, okay. Ooh, you know what the cool thing is? I can start over. Oh, okay. I went to the wrong one, didn't I? I went to this one when I should have been going to that one. You see that? I skipped it on accident. All right, so I'm going to connect this and that, and there. There we go. That's better. Can you see it or no? It's a reflection over y equals x. You didn't like that one, did you? It's pretty bad. But that's the idea. Take all the x's and y's, and you switch them. If that's on a grid, that's a lot nicer. You have notability, and you can pull up a grid for that. It's a lot better. All right, let's do one more of those. Number 5. Suppose that I have a function. Here it is. It's a cubic function that's been shifted up 1. Okay? And I want to just graph. I don't want to come up with the equation. I'm not trying to look for that. I just want to graph the inverse of that function. Okay? This is y equals f of x. And I want to graph y equals f inverse of x. And is it going to be a function, my new one? Yeah, because this is 1 to 1. All right, so this one I only really see one key point. Do you see that one key point? This point right here, which is the point 0, 1 becomes what? 1, 0. Perfect. Okay, and then you try to like flip everything, right? Oh, you know what a really good thing to do is to draw the line y equals x. And then you know this is going to be a point on the line. Anything on y equals x will be a point. And so you can kind of round it out that way and go that way. Ooh, that's pretty. How'd yours turn out? Better than mine? Yeah? See how it's a reflection if you were to fold that over the line y equals x. Those are tricky, huh? Especially when we don't have a lot of points. I just had 1 on that one. It's kind of tricky. Okay, now 1/6. We're going to go on to 1/6 now. That's all inverses and functions and stuff. And 1/6 is what I've been talking about kind of all along. This used to be at the beginning of the chapter, and now they've put it towards the end, which I think is kind of weird. But 1/6 is all about not using your graphing calculator to graph. Okay? We're going to do some graphical transformations. Graphical transformations. You know how like that last one, I said, oh, that's just a cubic function shifted up 1. Or sometimes I'll say y equals, like for example, you don't need to write this down, but if I say y equals x squared plus 5, I know what that looks like already because that is just a parabola that's been shifted up 5. Looks like that. And I can just graph it really quickly in my head or on paper, just a sketch, okay? So what we're going to do is we're going to do some transformations. We're going to see what happens to different functions when they move around and what moves them and stuff like that, okay? All right, so part A, we're first going to, part A, that's cute. We're first going to start with vertical and horizontal shifts and how those affect our function and which one's which. And these are the ones that you've done before. You did these with absolute value graphs and parabolas last year. Vertical and horizontal shifts. Okay, if you have y equals f of x, and then you add a constant to it, like the last one I just did, x squared plus 5. That is going to shift your graph up c units. Any graph. F of x can be anything. It can be a radical. It can be any of those 12, remember those 12 functions we studied a couple days ago? It could be any of those. And when you take that function, you just add a constant to it, everything gets shifted up. Okay? Same thing, if you subtract a constant from it, it will shift it down c. Down c. All right, so those are your vertical shifts. Horizontal is a little different. Horizontal is if I take y equals f of x plus c inside of it, okay? That is going to shift it to the left, c units. To the left. It's the opposite. Whenever it's inside of the function, it's making it go the other way, left or right. If you have y equals f of x minus c, then that would be to the right CML. Okay? All right, so out of those 12 graphs that I gave you, you don't need to know them all. That would be crazy right now. The ones that you need to know, let's go ahead and I'm going to write down the ones you need, okay? You need to know what y equals x squared is in your mind, okay? You know that's a parabola. Hope you know that. And you should know the basic graph goes through 0, 0, 1, 1, and negative 1, 1. We're going to take that, we're going to move it. It's like you take it and you click it on your computer and you're moving it around with your mouse, okay? No one has a mouse anymore, huh? All right, what about y equals the absolute value of x? That's another one that you need to know the graph of. Yeah, it's the basic V shape. Okay, goes through 0, 0. Actually, it goes through 1, 1, and it goes through negative 1, 1. And it almost does what a parabola does, but the parabola rounds out and the absolute value keeps going straight. You also need to know the basic cubic function, y equals x cubed. Okay, that one kind of looks like a parabola on the right and then a reflected parabola down on the left. So that's a cubic graph. That might be one that you're not used to as much. So we didn't do that one that much in Algebra 2. Okay, but you need to know it. And then the last one, you only need to know the four, like the main four. The other ones we're going to study more in depth later on, but these are the ones we're going to shift. And that would just be the radical, which is half the, bless you, the top half of a, sorry. I'm getting sick. And I've been getting sick since Sunday. It just won't really happen. So maybe I call in sick tomorrow. What are we doing? Oh, you'll be fine. All right, y equals radix. Okay, so here we go. Number 1. Knowing those graphs and knowing the shifting that happens with them, let's do some. Let's graph by hand, okay? No calculator. There will be a non-calculator section on your test on Tuesday. We're going to graph by hand these graphs. Here we go. Letter A. Let's graph y equals x minus 2 squared plus 3. Whew, I just kind of threw us right in there, didn't I? All right. Right now, it's just x. There's not going to be a 2 in front or anything like that or a negative, whatever. Okay, we're just going to graph these. This is a shift. It's 2 shifts. We have a shift of 2 to the what? Right. To the right and 3 up. Okay, so we're going to take our basic parabola, which is this guy right here. And if you want to draw your basic, it's called a parent function. If you want to graph the parent first, you can. And then you're going to graph the child, I guess, the offspring of it. Okay, so we're going to go 2 to the right, 1, 2, and 3 up. So I take that vertex, which is at 0, 0, and I shift it 2 to the right and 3 up. And it's just a sketch, okay? It doesn't have to be perfect. It is up 1 and over 1 in each direction, but it's just a sketch. Do you remember doing these last year? You did. Okay, B. Let's do another one. F of x equals, thanks, Julio. Shout out to Julio.
I heard you called me Julio.
Julio, I did not. Someone else did.
That's not what I heard.
Nope. You hear the wrong thing. Go to the tape. All right. F of x equals x minus 3 plus 1. Nope. I told them I was calling you the wrong name, and then you told me to not do that, which was good. And now I won't mess it up at all. Now you're the only name I know. So what? Sorry, Jeanette. All right. Here we go. We're going to take our basic absolute value graph. Here it is. Up 1 over 1, up 1 over 1, both directions. And we're going to shift that mother function over. Did I say something wrong? That's the parent function. I was saying the mom. We're going to shift the mother function over. 3 to the right. I woke some people up there, didn't I? And that's on tape. Great. All right. and 1 up. There you
Sam needs a chill pill.
go. That's fun. Okay, let's do one more.
How long have you been planning that
No, I say that every year. Yeah. Especially with the asymptotes, right? When I say, holy shift, look at the asymptotes on that mother function. Yeah. My nephew taught me that. He's in college. No, he graduated. He's way out of college now. Okay. Here we go. He told me his calculus teacher in high school used to say that. He just thought it was the funniest thing ever. All right, here we go. Let's do y equals, last one. And you don't have to have a vertical and horizontal shift. You could just have one. Let's do x plus 2 cubed. Cubics are probably going to be the hardest ones for you because you don't remember them the most. Oh, okay. So this one, we are going to take a cubic function, your basic cubic function, which looks like this. And we're going to shift that 2 to the left. To the left, to the left. All right, to the left. Were you thinking that? You totally were. You were so Beyonce right now. All right, there you go. That's it. Isn't that fun? Aren't these fun, you guys? Now, you should be pretty good at like visualizing graphs in your mind with the shifts and stuff, okay? They also want you to do something kind of weird with each of these. So if you look at this one, they want you to write the parent function with the shift involved. So, like, for example, this one, using the parent function, they would say f of x minus 2 plus 3. And the parent function was just x squared. Okay? It's kind of a weird way. They might ask you for that. I'm not really that particular. This one would be a shift of the parent function, 3, and then plus 1, where this time the parent function was the absolute value of x. It's just showing you that you can take any function, and when you shift it that way, that's what happens to it. It doesn't matter what the function is. What the function? Okay, so here we go. Part B. Ooh, we're cruising. Part B. We're going to do some reflections now. And these are a little tough. I must warn you. Reflections. Okay? We have reflections, and then we have stretches and shrinks, which are even worse. All right. Reflections. Now, if you take y equals negative f of x, okay? Y equals negative f of x. This is going to be a reflection across the x-axis. Across the x-axis, okay? Because what you're doing is you're taking your f of x and you're saying, no, let's make all the f of x's the opposite. So reflecting, you're changing all your y values over across the x-axis, okay? If you do y equals f of negative x, so now you're changing the x itself, and think about like a grid, and you're over on the positive x's, you're changing them to the negative x's, that's going to reflect across the y-axis. And if you just want to memorize that because you don't think that you could like figure that out, these are tough, okay? If you do both, negative f of negative x, that crosses over through the origin, which the book says, but you don't really need to know that because you can just do them separately. Okay, so let's do one. Here we go. Number 1. Number 2. Okay, let's go ahead and graph f of x equals negative square root of x. It's a really big negative. I don't like it. It's too much. There we go. Let's graph f of x equals negative rad x. So let's start with, our basic rad x graph. Rad x is just a radical function, looks like that. And we're going to take that and we're going to flip it. So this negative's on the outside of the function. It's not next to x, it's on the outside. So what we're doing is we're really changing all of our y values from positives to negatives. So this is going to reflect across the x-axis. To reflect over the x-axis, it's like you're, flipping it down. And so this would be the graph of f of x. Okay? Not the blue part, but the black part. That's the graph. You can check to see if your answers work too. Let's try number 3. Let's do this one. F of x equals negative square root of x plus 2. Let's try this one. Negative square root of x plus 2. Okay? I like to start with the parent function. Sometimes I'll draw it in a different color. Sometimes I dot it because I know it's not part of my graph. I'll dot it. And I know that I need to shift 2 to the left. So that would be over here now. Okay? And the negative tells me to reflect over the x-axis. So my graph would be right there. And that's it. Okay? On this one, I could have reflected first and then shifted. It didn't matter. I like to usually shift first and then reflect. Some of them it matters, though, which order you do it in. I'm going to show you a tricky one in a minute. Watch. If you ever get confused about what's happening, the negatives on the outside or the negatives on the inside, if you look at a negative x squared, or if you look at a negative x being squared, okay? This is the one where it's on the outside of the function. This is the one where it's on the inside of the function. Now, everyone knows that a parabola that has a negative leading coefficient faces which way? Down. It's sad, right? Everyone knows that. Okay? What did I do? I reflected my parent function over the x-axis. Okay? If you ever mess up, go to something very basic. Now, what happens with this? Nothing, right? What's negative x squared? It's still x squared. So this reflects over the y-axis and nothing happens to it. It doesn't change. Okay, that's why these things are the way they are. Now, let me do one which really messes with people. Number 5. This is the last one of these, and then we'll go to stretches and shrinks. Let's do y equals the square root of negative x plus 2. Okay. Now, a lot of people will look at this and they'll think, okay, we have to shift 2 to the left. And that's not right. You're like, what? That's a plus 2. Well, but it's a negative x. If I had y equals the square root of x plus 2, yeah, I would shift that 2 to the left. But now I have a negative x plus 2, so things change. Some people like to do it this way. They'll take that negative and they'll factor it out. So now it's a shift. Now it's the correct shift, right, of 2 to the right. Okay? Because just shift is on x. It's not on negative x. The shift has to be on x. All right, so for this one, we start with our parent function. Okay? And we're going to take that, and we're going to shift 2 to the right. And we're going to reflect over the y-axis. Okay? So here's the way you have to do this. You have to, if you're going to do it this way right here, you need to reflect first and then shift 2. Okay? So if I reflect first, here I am. Ew, that's gross. Here I am, reflecting. I'll dash it because these don't work. Okay? And then I'm going to shift 2 to the right. 1, 2. So here's my graph right there. You can also plug numbers in to see if they work. If you're ever stuck, like on a test or quiz, do old school. Make yourself a T-chart, okay, if you get stuck on these. Because this one's really tricky. Like, which way do I go? Da-da. Some people like to do it this way. They'll take the original, which was y equals the square root of negative x plus 2, and they will shift 2 to the left because they think they're shifting 2 to the left. Here's their graph. And then they'll take the whole thing and reflect it. And guess what? That gives you the right answer also. But you had to shift first and then reflect. So I prefer this way because this is actually a wrong shift because it's a shift on negative x when it should be a shift on x. But either way, you get going the right direction. All right, last part. Stretches and shrinks. What part are we on? C. Are we running out of time? I know I'm talking a lot. It's been 45 minutes. Do you need a break on this one?
Yes.
Yes. Let's take. Okay, we're going to do some stretches and shrinks. Sounds like a PE class today, huh? We reflected, we moved vertically, horizontally, and we're all just sitting there. Okay, fine. Stretches and shrinks. Okay, so there's two types. We have a horizontal stretch / shrink, and a vertical. All right, so let's do the horizontal first. Horizontal would be y equals f of x divided by c. So you take your x and you divide it by a constant. Okay? This is going to be a stretch. It's going to be a stretch if c is greater than 1. And it's going to be a shrink if c is less than 1. Okay? Now, horizontal is the hardest one. The vertical is not so bad. Vertical is actually pretty easy. Vertical, all you do is you take that c and you multiply the entire outside function by it. Okay, the horizontal is a little tricky. You got to put that 1 over c or x over c in there and deal with it, and it's pretty bad. All right, here we go. Let's try one. Number 1. All right, let's say that f of x is equal to x cubed minus 16x. X cubed minus 16x. And we're going to do a couple of things to this. Okay, so we're given this function. It's not a parent function. It's just some function that's been shifted and stuff, and we don't even know. But what they want us to do, why did I write number 1? Whatever. What they want us to do is they want us to stretch this thing vertically. Stretch vertically by a factor of 3. And it's as easy as you think it's going to be. You stretch vertically by a factor of 3. You take that constant 3 and you multiply the entire function by 3. Okay? So we're going to go 3 times f of x, which will equal 3x cubed minus 48x. And that's your answer. And that's it. Nice, huh? Yeah. It's a vertical stretch by a factor of 3. What that's doing is, you know, like a parabola, when you have like just a regular x squared parabola, looks normal, and then you put a 2 on there and all of a sudden it like stretches it out pretty thin. That's what the 3 is doing here too, to the cubic function. Now let's do this, part B. This is the tougher part. Now let's go ahead and horizontally shrink it by a half. We want a horizontal shrink of 1/2. Okay. Horizontal shrink of 1/2 is going to be this. F of x divided by a half. The constant is going to go, it's going to be f of x over c, and c this time is 1/2. Now nobody likes that, right? X divided by a half. That's the same thing as f of 2x. Take the bottom 1/2, flip it, and multiply instead. And so now we have to evaluate this function for f of 2x instead. So what is f of 2x? Well, it's 2x cubed minus 16 times 2x. So instead of f of x, it's now f of 2x. And then we can go ahead and clean it up. That becomes 8x cubed minus 32x. And that would be a horizontal shrink by 1/2. Okay, and that's all you have to do for those. They're not that bad. They're a little tricky. All right, and then the last thing they're going to have you do is this. Let's say you start with your parent function y equals x squared. And they're going to tell you that they're going to do, in this order, they're going to shift it 2 to the right. They're going to do a vertical stretch by 3. Vertical stretch of 3. and then they're going to move it up 8. Shift up 8. So they want you to come up with the new equation. You don't have to graph it. You don't have to actually do it. But they want you to take these 3 things that they've done to your parent function to create an offspring, and you're going to give us the new formula for it. Okay? In that order. All right, so start with a shift of 2 to the right. What would that look like? Perfect. Y equals x minus 2 squared. Yeah.
Is it possible to put that negative on the other side, like so it's like?
No, because it's in the parentheses with the x.
Okay, got it.
Yep. All right, now we're going to do a vertical stretch of 3. A vertical stretch of 3 takes that constant 3 and multiplies our equation by that. So we would get y equals 3 times x minus 2 squared. You do not need to FOIL that out. You don't need to distribute the 3. Leave it alone. And then I'm going to, after I've done those things, I'm going to shift it up 8. Plus 8 on the end. And the 8 is not affected by the 3 out front. Okay? And that would be your answer. Hi, good morning. Let's try one more. Is it the same thing? It is. Oh. All right. Nope, that should be good. And that's the last one.